Hello everyone, I'm Sanaula, a PhD student from Bielefeld University, Germany. Today I'm going to present a spike vision approach for multi-object detection and generating spike-based dataset using multi-core architecture on edge devices. Let's begin. We will go through the following chapter. We will first introduce the neural network, different neural network generations, and then go to the introduction, objective behind this study, and then we will discuss about the detailed discussion on the proposed architecture and demonstration, and finally we will discuss about the future direction of this study. So generation of neural network. Researchers and scientists categorized a neural network in three different generations. The first generation was perceptron neuron, which was introduced by Frank in 1950s. It is capable for only a binary classification task. Then in late 1970s and mid 1980s, research introduced second generation based on multi-layer perceptron and convolutional neural network. Convolutional neural network till date is the most widely used neural network in almost all the domains. But these two generation of neural network was inspired by the human brain, how human brain is capable of doing such complicated tasks such as recognizing object, decision making, and so on. But then, as we know that the currently large language model are consuming a lot of computational power, and which are definitely cost of expense of in sense of the energy, right? So researchers focused again on the how human brain is capable of doing such big complicated computational task in such a lower power. For example, human brain is capable of doing task in only 20 watts. So based on this inspiration, they introduced a third generation called spiking neural network. Let's start. Spiking network have gained significant attention recently in the field of neuromorphic computing because of due to their ability to simulate behavior similar like the biological neurons found in the human brain. So the functionality of the spiking neural networks, the mechanism in that sense works like that when the neuron generates spikes, when the input reaches a certain threshold. So for example, we have the input from the convolutional neural network. It's a continuous value. So in any case, because we are receiving a garbage value, noise, and so on, so the model continuously execute the task from till to end, mean that from the start to end. But on the other side, spiking network is based on discrete event. So it's mean that it will compute the task only when there is some kind of event, some kind of triggering point occur, and only for those values. So in theoretical, it is like more energy efficient and more powerful computation on the model because it is neglecting the noise and the garbage values, which is not really necessary for to compute every time the whole algorithm, so on. So how the spiking neural network works. For example, on the left side, you can see biological neural processing, right? So we have a neuron 1. When the neuron 1 input goes a certain threshold cross, then it's generate the axon terminal, which is like a presynaptic neuron, pass to the postsynaptic neuron of the neuron 2. But this part is the second neuron is a presynaptic neuron, and when it crosses a certain threshold, then it will go to the output of neuron 2, which is the neuron 3 input, and further on, so on. So in sense of the implementation part on the artificial neural processing, we have a pre-neurons. When the pre-neurons are their weights like the spikes are generated, then their weights are summed, and then we are sending this information to a neural model. This neural model, we have a bunch of neural model in spiking neural network, and these differential equation based neural models are the main core architecture point in the spiking neural network. And these are the functionality like how the neuron has to be send information to the next layer of the neuron and so on. So this we use the leak integration fire neural model. And why we use the leak integration fire neural model, there is a bunch of reasons. We have did our primary research on these things, and then we found that leaf is the balancing between the cost and the accuracy in terms of classification tasks. So, for example, let's say that how the leaky integration fine neural network works. In every biological mechanism in which is found in the human, with let's say we have two protein, neuron 1 and neuron J, we can consider as a pi of J and pj of I, protein 1 and protein 2. When protein 1 and 2 intersect at certain level, then it generate a green fluorescing protein. That's how the biological synthetic biology mechanism works. In the similar way, when the neuron 1 generate a specific threshold level, then it go the signal to the neuron 2, which is we call the spike 1, and in this scenario, and then it goes suddenly to the refractive period. This refractive period is the period where none of the action will perform. It's a certain small period of time, and then it will start again to see the getting the input from the previous pre-neuron or the synaptics of neurons, and so on. So this is the general basic overview of the leak integrated defined order and plus the whole spiking network. So what makes the spiking network differ from the typical neural network? As we said that the spiking network transmit the data when their membrane potential reaches a certain threshold, unlike a traditional neural network that use the continuous value encryption. So this discrete event-based information is appropriate for tasks such as sensory perceptions or object detection and autonomous driving control system and so on. There's a bunch of other reasons as well, like a neural model, each neural model has a bunch of hyperparametric values, and these hyperparametric value is balancing between these hyperparametric value is quite challenging stuff. Like you need to be your previous knowledge to now, otherwise you have to do the head and trial error method, which takes a lot of time to find the appropriate set of the balancing set of the hyperparametric values. And then we have a power consumptions, as we said that it is more friendly. And the most importantly, SN is inspired by the human brain energy conceptions approach. As I said that the previous two generations are based on how human brain is capable of doing a complicated task, but the spiking neural network is also inspired by the how human brain is capable of doing such task in such a small amount of energy. So let's talk about the proposed architecture. The proposed architecture is consist of strategy incorporation or in different stages. For example, we have object detection plus the classification, which is done by the transfer learning, and we are doing a human counting here, human detection and plus the human counting with the event-based camera and non-event-based camera. Why we use the event-based camera and why what we have done the algorithm implementation with the non-event based camera we will discuss on the further slides. We are doing the localizations, real-time tracking, and the most important spike train data set. As I said, the spiking network is a third generation, which means that it is required the data set which is based on the spiking neural net, spike train data set. For example, in convolutional neural network, we can feed the data set, which is bunch of we have a benchmarks available, but those benchmarks might be not good to feed directly into the spike network. We have to do a conversion. So conversion takes a lot of time, and for that purpose, we thought why not to create design application which create the real time spike train data set for specified for the spiking network domain. So in algorithm form, we are doing data input sources. We will see that event-based camera and non-event-based camera, and then the network learning, where we will discuss about the transfer learning, like a parent-child concept. We propose a long-life learning agent. Then we will discuss about the neural model core architecture, where we will discuss about the leak integration fine neural model and spike vision approach for generating large-scale SNN-based data set. And then finally, we will discuss about the execution on the edge devices and the difficulties which we faced during the implementation part. Let's talk about the data acquisition. It is capable of obtaining, the proposal algorithm is capable of obtaining input data from variety of sources. We have event-based cameras and non-event-based cameras. Event-based cameras are quite expensive. It is not similar like which we are using cameras, non-event-based cameras. If you know that the event-based camera is quite expensive, even such a small pixel pixels produced camera TVS 346 costs us 4,700 euro. So, and their connectivity is not like a straightforward, like a USB plug-in. There's a bunch of things. For example, for Windows, you can see that this like DV simulator, this has to be this is the main platform where you can connect this camera to your screen, I mean your algorithm. So here you have to create a network, and then that IP you have to pass to your algorithm, and then it is able to get the data from directly from the camera. But the problem is, like, if you have to execute you have to implement this camera use on the edge devices such as NVIDIA Jetson, then you have to be face a lot of difficulties because they have no support from the ARC operating system. And for the ARC operating system, you have to pass this simulator directly to this your algorithm. And doing such a thing, you have to go through a lot of implementation by your own side, and we will discuss further on it. Then the non-event based camera we use for this implementation a normal USB plug-in camera, right? The key innovation is to introduce the tracking mechanism. For example, the event-based camera and non-event based camera, the difference is like event-based camera continuously sending the information, non-event based camera continues sending information to the algorithm, and algorithm every time checks all the things like what he is receiving, it is receiving, and then it is a garbage value or not, and so on. So it's a extra like computational expense, which we thought why not we neglect using a non-event based camera, and we introduce a triggering point, which is also found in the event based camera, where the event based camera only sent the signal to the algorithm when it thought that it detects some certain level of a threshold. It's like a spike cameras, which is used for specifically for the spiking network. Like the similar, the neuromorphic computing hardware is required for a neuromorphic computing application. So you can use it on vice versa, but it will not be a friendly, as it will be friendly on the same domain. So the same way, like we thought why, because it is expensive, and in research we don't have a lot of funds to see the stuff. But later on somehow we got the fund and we are able to order the DVS 346. But until we didn't order 346, we designed a framework which like a similar behavior of the event based camera. It allows the non-event based camera to perform like event based camera and send only the relevant signals to the algorithm. Then we have a network learning. As I said, we use for here the transfer learning. For example, let's discuss about the parent and child concept. One thing, it is object detection. There is if we are going from a scratch to design object detection application purely on a spiking network, it will take us a lot of time, because we believe that a YOLO algorithm is one of the best algorithm to detect objects, right? And might be we were not able to compete that kind of accuracy, as they had did a lot of research, a lot of people, I mean, great mind, they work together and they built these things for many of years. And we thought it's a challenging stuff, and then why not to use a reuse engineering frame concept and to use the YOLO as a parent model. Why it's a parent model? Because our child model, which is based on the spiking network, use the initial information from the parent. Like the parent model teach them child model, like this is the human and this is the ABC and so on. But every time the neural model, the child neural model, when it runs again, it use his own information, which he learned from the previous running stage, and to execute in the future. So our long life learning agent we didn't discuss at the moment because it is on the initial stage, and we are still working on this part, and soon we will introduce the long life learning agent, which is capable of learning the things by itself without requiring any further training. And then we have a event-based camera, and event-based camera is as I said that it's detecting the stuffs and then sending the data set, and that data set also linked with our child model for the next. And as well as this spike train data set is also available for other users to use for their own specific applications, right? So then the neural model core architecture, as we said that we use a leaky integration file neural model. Leaky integration file neural model, why it is we use, because we thought it's a balancing neural model with as compared to the other available neural models. As you can see, the edX perform better in all sense, like, but if you will see on the computational side that the edX model perform the worse as compared to the leaky integration fine neural model, because we have to implement in our edge device where the computation is quite important for us. So that is the reason we choose the leaky integration fine neural model. SRM perform better than the edX, but if you will see the SRM here, the accuracy and error was lower than the leaky integration fine neural model. So that makes sense that use the leak integration finder model in our specified application. But if you are focusing on the accuracy and error, you can go through the, I think the ADX is a better. So as we discussed the leak integration find your model earlier, that leak integration find your model is like send this the spikes preceptive neuron to the postceptive neuron when they have a certain threshold, and then there is a refractive period. This is these are the hyperparametric value which is required balancing set, and that you have if someone want to implement spiking network, they have to be get to know about these hyperparametric values, and these are the physics-based value, which is quite difficult to know because these are minor change in the decimal value, and it will reflect the results a lot. So for doing this one, we introduce a raw sim, a runtime analysis and visualization simulation and a simulator tool, which is available publicly. You can learn at the runtime about the neural models, the concept of these hyperparametric values, and you can even train the model, and even you can do a comparison, like this comparison between the neural model accuracy, computationals, and so on, biological pulsability, everything you can done here on at the runtime. So we would recommend to use this. Our simulator is freely available publicly on the LabVIEW official platform, and these are the demonstration user manuals and the links, which is might be someone useful for someone who want be interested in the learning about the spiking network. And you can even also generate the classification task model for your further. You don't need to be worried about the backend coding. You can just give the data set, and the data set can where you can train into classes, and the accuracy till now is good, and you can use a raw data set as well. But also you can also pre-processing of the data sets is also done by here. Then the spike train data set. As I said, the spike train data set is one of the core implementation in this proposed algorithm, because the spike train data set allows the child model to learn for the future information. So in the similar way, like spike train data set also useful for the other domains, like for example, like object detection, and if someone has to need a triggering point, a single point, so they can use the data set for more analysis. So this spike train data set, we are saving such information like a object ID. We are giving each object one ID. For example, human is object 0 and class will be 1 and so on. And the bounding boxes, which is required to know about the information, and the spike trains, which I said that the spike trains base data set it is, and the computed features X, Y, and so on. So we believe that these informations are quite important for a model to learn every time, and these are the information which is required for further analysis. Finally, we discuss about the hardware, like we implemented using a NVIDIA Jetson device. NVIDIA Jetson, we use the Jetson Xperia NX, which is a 8 GB and launched in May 14, and but it is already end of life, so in 2022. So it's a minimum hardware which I believe that NVIDIA is providing for edge computing. Yeah, there is also a nano 2 GB, 4 GB, but that one is like for mm, more optimized application and more low level application as compared to like our such complicated algorithm where we are doing a learning as well. So we need at least this minimum hardware. And yeah, so we use this NVIDIA Jetson for the our hardware implementation. The practical demonstration with the event-based camera and non-event-based camera, as you can see that we demonstrate with the TVS346 USB camera and NVIDIA Jetson Xperia NX device, where the human detection in the real time. Then, as we discussed, like it is basically a cost-effective, completely cost-effective. So you can see that it's a non-event based camera, okay, right? So our framework, you can see that there is a no computational cost expense unless there is a no event. Once the event starts, the human detection, the computation cost goes up to the maximum level. So the future directions, as we said that the performance comparison on different NVIDIA Jetson, we are working on the Nano, Orion Nano, Xperia NX, and Orion AGX device, and we are seeing that which is the balancing between power as well as the real-time accuracy and so on, and enhancing our lifelong learning agent, which we discussed, like the child model is capable of doing learn the stuff without getting the the further training required. And expanding application domain, we are thinking to expand this application not only the object the human object detection, but also detect the further objects which we can give the initial like a dynamic learning concept, and then the model has to be keep the data and for the future learning. So conclude, a simple yet effective architecture that use the power of neuromorphic computing to detect and analyze human presence in real time, utilizing event-based cameras and non-event based camera. The spike train dataset capture critical information, allowing for various applications such as behavior analysis and real-time monitoring. The efficiently demonstrated the proposed application in real-time environment on the edge computing edge devices such as NVIDIA Jetson, and mm, the groundwork for an online learning method, removing the need for repetitive training throughout the product lifecycle. You can scan the QR code. You can go to our project webpage where you will find the more detailed results as well as the code. And if you have any question, please let us know. Thank you.